In the Wan 2.2 Animate page, you can see a diagram explaining how the process works. The vision inputs are a reference image and reference video with movements of a person. The reference video is converted to control signals using DWPose skeletons. The reference image is converted into a latent using the VE encoder. The converted reference image and video is then used by the transformer to create the animated video. For subject replacement, you will also need to create masks for the subject. Like all the current diffusion models, the animation is done in the latent space, and is then converted into the pixel space by using a VE decoder. Open a blank canvas and let's get started. Add a K-sampler, which is the core of the transformation process. We start here, as it is easier to know what is required for each step of the workflow. The output latents will need to be converted into pixels, so we use a VE decode node. This step requires the VE model, so we connect it to a VE load node and select the Wan 2.1 VE model. The batch of images need to be converted into a video sequence. Create Video and Save Video are native nodes of ComfyUI that can be used. However, I prefer to use the Video Combine node from the Video Helper suite. We set the frame rate to 16 and change the format to MP4. Let's continue building the workflow to the left. The diffusion process needs the diffusion model to be loaded. We add the Load Diffusion Model node and select the Wan 2.2 Animate model we downloaded before. To improve the performance, we are using in this workflow the Relight and the LightX2V LoRAs. Add two LoRa loader model only nodes. Then select Relight and LightX, one in each node. Wan video workflows use shift. So, add the model sampling SD3 node, and set the shift to 8. Now we connect all the nodes together in series, and the last model sampling node to the K-sampler. Select these 4 nodes and press Ctrl-G to create a group. This will help to easily move around these nodes and keep the workflow tidy. Next, we need to feed our transformed vision inputs and prompts, in the right way, to the sampler. Add the Wan Animate to video. Connect the positive and negative conditionings. Then the latent to the latent image slot. There are other outlet connections, but for the moment we will not do anything with them. We have to connect positive and negative prompts to the Wan Animate to video node. Add clip text encode nodes for both. The text prompt is converted into embeddings, that are then used in the sampler. This is done with a clip model. Use a load clip model for that. Select the UMT5XX model. Select one as type. You can group them as we did with the diffusion models before. The reference image has to be encoded, so we connect the VAE model to the V port. We also need to connect a clip vision output and the reference image. Add a load image node, where you will later upload a reference image. Connect it to the reference image port in the Wan Animate node. Connect the clip vision output port to a clip vision encode node. This node encodes the image for the sampling process, using a clip vision model. Connect the image and the load clip vision node. Select the clip vision H model and set crop to none. Group them to keep the workflow tidy. The next step is to add the control videos. One port is for the face, and one for the pose. Add a load video upload node to upload the video we want to use as animation reference. We will use one of the typical dancing videos for this example. With the video upload node, we can pause and hide the preview, which is useful if you have a sluggish browser as I have. Add an upscale image node. We use it to make sure to convert the original video to a resolution that can be handled by Wan Animate. Connect the load video node to the upscale image node. We could type here the resolution, but we also need the same width and height in other nodes. It is better to use 2 integer nodes for the resolution, which will be connected for width and height in several nodes. I advise to name them to make clear which is the width and which is the height. Set the right values and then connect them to the width and height widgets in the Upscale Image node. To generate the pose and face movements, add two DWPose estimator nodes. Rename them to be sure which one is for the face, and one for the body pose. For the face, disable the hand and body detection. For the pose, disable the face detection. Add now a pixel perfect resolution node, which will adjust the preprocessor resolution to the dimensions of the images. Connect the image from the Upscale Image node to the Pixel Perfect Resolution node. Then, the resolution output to the widgets in the face and pose preprocessor nodes. Connect the image and width nodes to the widgets of the Pixel Perfect Resolution node. Change the upscale method to Lanxos in the Upscale Image node, and connect the image output to the input of the face and pose detectors. If you forget one, like I did, you will get an error easy to solve. Finally, connect the faces and poses to the corresponding inputs of the Wan Animate 2.2 node. All connections are ready. Let's complete setting the parameters of each node. For this animation, we skip the first 144 frames. In your case, it will depend on what part of the video you want to capture. Set the frame load cap to 77, as this is the number of frames we will process in one step of Wan Animate. For this video, we select every second frame. Let's choose now the reference image we want to animate. Set the crop to none in the Clip Vision Encode node. In the positive prompt we use the girl is dancing. Although the visual inputs are more important, it is always good practice that the text and image embeddings do not contradict with each other. In the Wan Animate node we need to define the width and height of the resulting animation. To make sure they are the same across the workflow, we connect the width and height nodes defined before to the widgets in the Wan Animate 2.2 node. In the K-sampler, change and fix the seed. Because we use the LightXV2 LoRA, we reduce the number of steps to 6. Change the CFG to 1 and keep the rest of the settings. If everything is set correctly, you can now run the workflow. As I showed, I forgot to connect the image input to the pose preprocessor. After fixing it, I can run it again. Take into account the first time the 6 models need to be loaded, and that the 77 frames are being processed 2 times by a DW preprocessor, which is slow. So be patient while the workflow runs. As you see, the first frames of the video created contain our reference image. This happens with all Wan models. To fix this, we use a Trim Video Latent node. Connect now the latent from the K-sampler. Then, the output latent to the VE decode node. Use the Trim Latent output of the Wan Animate node and connect to the Trim amount of the Trim Video Latent node. We only need to run the last part of the workflow. Click over the Video Combine node and press over the play button over it. The Trim Video Latent has removed the first frames of the videos with the reference image, and we can see a smooth animation. We can concatenate the Wan Animate and K-samplers to extend the video. However, this makes the workflow look messy. Let's use the Subgraph feature to keep it clear and make the extensions much easier. It is nice, but we missed some connections that we are going to need later. Let's unpack the Subgraph, so we revert to the original structure. Connect temporary reroute nodes to the background video, character mask and continue motion inputs in the Wan Animate 2.2 node. Do the same for the video frame offset widget. And for the video frame offset output. Select now the Wan Animate 2.2, K-sampler, Trim Video Latent and VE decode nodes. Right-click and choose Convert to Subgraph. Now we have all the input and output connections we need. You can delete the reroute nodes. Duplicate the subgraph block. Use Ctrl-C and then Ctrl-Shift-V to keep the input connections. Connect the image output of the first subgraph to the continue motion input of the second, and the video frame offset output of the first to the input of the second. You can do this concatenation of subgraphs as long as you need. In the last, connect the output image to the video combine node. Let's increase the frame load cap to 154 to check what is the result of this configuration. We are not done yet, but let's see what happens when we run the workflow. The resulting video only contains the animation of the second K-sampler. However, we want the complete 154 frames. Open the second subgraph. To stitch the videos, use a batch images node. Connect the continue motion image slot to image 1 in the batch image node. Naturally, we would connect to image 2 the decoded images from the second sampling process, and the combination to the outlet image. However, if we only do this, some frames repeat. By setting the continuation frames to 5, the last 5 frames of the first subgraph are also the first 5 frames of the second. We need to avoid the repetition. For this final fix, add an image from batch node. Connect the image output of the VAE decode to the input and reconnect the output of the image from batch to image 2 of the batch image node. Connect the trim image output from the Wan Animate to video node to the batch index of the image from batch node. The length can be any number larger or equal that the total of frames to process. A solution is to use one of the image count nodes and count the number of frames of the pose video. Connect the pose video port to the images input of the getImageCount node. And the count, connect to the length in the image from batch node. Now, our concatenated subgraphs should work. Let's run it again. The resulting animation is now composed of the 2 animations created in each sampler, without overlap and without the reference image. You can now extend the animation duplicating the second subgraph over and over again until all the video frames are processed. Just connect the resulting video image to the continue motion and the video frame offset. We will not show further concatenations though. After cleaning and organizing the noddles, let's see how to use Wan Animate for replacement. We need to add to Wan Animate the background video without the character, and the mask of the character. Connect the frames of the video to a points editor node. With this node we can define the objects we want to mask, and which not. Connect the positive coordinates to a SAM2 segmentation node. SAM will do the detection of the objects indicated in the points editor. We have to connect it a load SAM2 model node. Select video in segmenter. The SAM model will be automatically downloaded if we do not have it yet installed. Connect also the image to the SAM2 segmentation node. Click on New Canvas in the Points Editor to load the default points position. When we run this part of the workflow, the first image of the video will load and we will be able to choose the objects to mask. Before that, we add first a Grow Mask node connected to the output mask of the SAM segmenter. A expand value of 10 is generally okay. Next, we connect the mask to a Blockify mask node. This will create a broader mask over the subject, which is useful for Wan Animate to blend the new character and the background. To create the isolated background, add a Draw Mask on Image node. We connect there the video frames and the mask created with the Blockify mask node. Connect a Preview Animation node to the background video and the mask, and run this part of the workflow to determine the right position of the object in the points editor. As you see, the green point is not located over the character, so the resulting mask is not the one we want. When we place it over the person, a new detection runs and hopefully works. If the resolution of the video is too large, it is better that you connect the output of the image upscale node to the mask detection group. This will make the running of these nodes faster. If the masking does not work, you can play around with the position of the green points. You can also add them by clicking with the left button of the mouse when holding Shift. It seems it is working, both for the character mask and the background video. Now we just need to connect the background video and the character mask to each of the subgraphs we are using for the sampling of the video. Run the workflow when ready. With the background video and the character masks, you can achieve the character replacement. The FP8 model does not look great though. Better results are obtained using the BF16 model. The link to the model is in the Wan Animate template of ComfyUI. When downloaded, select the BF16 model and the Load Diffusion model node and run the workflow. As you see, with the BF16 we do not have these small shadows of the mask anymore. But if you have memory limitations, the alternative is to use quantized models. You can download them from the QuantStack Hugging Face. The Q8 Quant is almost as good as the BF16 model, but it has the size of the FP8 model. To use it, you need to install the GGUF loader node. Go to the manager and click on Custom Nodes Manager. Search for GGUF and install the ComfyUI GGUF custom node. When ready, restart ComfyUI. Replace the Load Diffusion model by the Unnet Loader GGUF node. Reconnect and run the workflow. And that is everything. You have learned how to reproduce from scratch your own Wan Animate workflow. I hope you liked the tutorial and learned how to use ComfyUI. Bye.